Alright, so for this one, 3.26, we're going to apply mesh analysis to find the mesh current in the circuit. Use the information to determine the voltage V. So I'm going to solve this the easy way with meshes. I mean, there's a whole bunch of ways to solve meshes. V minus IR, and then plus that I. We're going to do it this way, and maybe this will help out, because I think this will eliminate some of the mistakes that I see. So let's move this up to here. And the first bit, we've already drawn our I1 and I2, so they've already drawn the meshes in this problem, which is kind of nice for us. So the first bit, let's solve for I1. What is this mesh over here? We've got I1. I write that one down first, because that's the mesh that we're solving. Well, that's the area we're solving. We're going to do all the resistors that touch it. So 2 and 3. So 2 plus 3. Now, we're going to do subtract any other meshes that touch any resistors, so any shared resistors. So we have this 3 ohms shared in between I1 and I2. So we're going to put our one that's going to be the shared, and that's going to be I2, and then we have our 3. And now to finish it up, we're going to have our source equals 16. That's a quick way of doing the whole V equals IR thing around the sides. But it's going to come out to 5I1 minus 3I2 equals 16. Okay, and that's our first equation. One, boom. We have two equations because we have two unknowns. So what's our second one? So we're going to start with this one. We're going to put our I2 first. And then we're going to do all the resistors that touch it. We got a 3, a 2, and a 4. 3 plus 2 plus 4. And now we're going to have a minus because this resistor is touching the I1. So we're going to have our I1 there and our 3 because this resistor is touching that. And then anything else equals our source. So let's take a quick look too. Our source is going the opposite direction of our mesh. See, before we could just add our source positive on the side because it's the same direction. This is going negative, so we're going to have minus 12 is our answer there. And then if we simplify this up, 7, 8, 9, 9I1, 9I2, so we're going to put this in front. So minus, minus 3I1 plus 9I2 equals minus 12. Okay. Cool. That's our second equation. Two equations, two unknowns. Now we solve. We make our little matrix I. Let's see if we get this I1, I2 number. This is going to be 5 minus 3, 16. And this one's going to be minus 3, 9, minus 12 equals I1 is going to equal to 3, I2 equals to 1/3. There we go. And is there anything else this problem is asking? Use the information to find voltage V. So they want us to find that node there. So how do we do this? So this is kind of cool. This is the conceptual side of this problem. The difference between this and this, what is preventing us from get to here? We have this resistor, and we have a current in this direction and a current in this direction. So we can use our normal V equals IR equation. This is the V we're trying to solve for. So V equals, and now what is our currents? Well, our current is the I1 minus I2. I1 minus I2. And then the resistor in between that they share is 3. So V equals, we already solved this, so 3 minus 1/3. 3 minus 1/3 times 3. V is going to equal to 3 minus 1/3, 2/3, 10 volts. Sweet. And can we see that? Yeah, and that's the answer, 10 volts. Cool.